Well, I'd like to welcome you all to the Physics Colloquium. Today it's my pleasure to introduce Professor Alan Robach, who's a visiting Miller professor. When he's not here visiting, he's a distinguished professor of climate science, Department of Environmental Sciences at Rutgers University. He got his PhD at MIT. Before that, he was in the Peace Corps in the Philippines. Prior to he's got his PhD. He was a professor at Maryland for 20 years, and for a 6-year period, was the state climatologist of the state of Maryland. So his areas of expertise include climate intervention, all geoengineering. He just told me that those of you who are interested, he'll be giving a EPS seminar on Thursday if you want to find out more about that. And then he's also an expert on climatic effects of nuclear war and the effects of volcanic eruptions on the climate. He has many honors, including being a fellow of the American Geophysical Union, the American Meteorological Society, and the American Association for the Advancement of Science. He was a recipient of the Jewel Charney Medal. He was the lead author of the 5th assessment report of the Intergovernmental Panel on Climate Change, which was awarded the Nobel Peace Prize in 2007. In 2017, the International Campaign to Abolish Nuclear Weapons was awarded the Nobel Peace Prize for its work to draw attention to the catastrophic humanitarian consequences of any use of nuclear weapons and its groundbreaking efforts to achieve treaty-based prohibition of such weapons. And this was based partly on Professor Robach's work. In 2022, he was the winner of the Future of Life Award for reducing the risk of nuclear war by developing and popularizing science of nuclear winter. So it gives me great pleasure to turn the speaker over to Alan.
Thanks very much for inviting me to give this talk. My work is sponsored by the Open Philanthropy Project, and some of the original work was sponsored by National Science Foundation. And I'd also like to thank the Miller Institute for inviting me here and for a sponsor visit. I'd like to start with an advertisement. I'm an editor of Reviews of Geophysics, which is the most highly cited journal in geophysics. If you'd like to send a paper, please talk to me. There's no pay charge. It'll be as long as you want, and it'll be very highly cited. This is the obituary of Sherry Rowland, who won the Nobel Prize in Chemistry in 1995, along with Mario Molina and Paul Crutzen. Mario Molina got his PhD here at Berkeley. He died, and what he said was, we'll see if we develop science well enough to make predictions if in the end, all we're willing to do is stand around and wait for them to come true. He said, it's enough for a scientist simply to publish a paper. Isn't it a responsibility of scientists if you believe you found something that can affect the environment? It's your responsibility to actually do something about it. So these sentiments are what motivate me to do this work. So I'm going to talk about nuclear winter theory. Obviously, we don't want to do the experiment. Analogs to test the theory, policy implications, and then doing something about it. And one thing you can do as physicists is join the Physicists Coalition for Nuclear Threat Reduction, which I'll tell you about at the end. The last time I was here in San Francisco was for the AGU meeting in 2019. We had a poster session. The old guys that worked, Rich Turco, Brian Toon, Tom Ackerman, me, and Georgy Senchikov, who worked in Russia and then came work with me at University of Maryland and at Rutgers. But we also working with a lot of young people. So we have oceanographers, crop modelers, and climate modelers. And Billy Lundquist works on urban fires. We published lots of papers about this. I'm not going to just tell you about a couple of them. Here's the story. Right, here's our full planet. It might look like this, with a cloud of smoke covering the planet, heated by the sun, moving the atmosphere, blocking out the sun, making it cold and dark at the Earth's surface. If there's enough smoke, we would get nuclear winter. Temperatures would be below freezing even in the summertime, and it would be devastating for crops. The heat of the atmosphere would also destroy ozone and let more ultraviolet radiation through later. We started working on this when Paul Crutzen, who shared the Nobel Prize, and John Birx wrote a paper in a special issue of Ambient 40 years ago on what would happen after a nuclear war. They're atmospheric chemists, and they were working on tropospheric ozone, and they realized that there would be smoke and much less sunlight. It's a chemical reaction. And oh, by the way, that might cause climate change. So right after that, everybody said, whoa, wow. So here's a graph of the total number of deployed nuclear weapons on the planet. The total includes all the countries. Can somebody tell me how many countries have nuclear weapons? 6, 8, 9, 10, 20. Okay. Usually the consensus is the best forecast, so you average them. So the correct answer is 9. The US and Russia, England, France, and China, and then Israel, North Korea, India, and Pakistan. All the total includes all of them, but US and Russia have more than 90%. So you can see their arms race. This isn't very bright. And then the why. President Birx wrote their paper here, 1982. Afterwards, there were 2 papers about nuclear winter, Russian Alexandrov and Stenchikov, and an American group, Tiedemann, Pollack, and Sagan. And the next year, another group at the National Center for Atmospheric Research wrote a paper, and I wrote a paper in Nature, and then the arms race ended. Why did the arms race end? Well, it wasn't the end of the Soviet Union. That didn't end for another 5 years. The arms was already over. Oh, and by the way, the number, it's still 10,000 or so. So that's why the problem is still here. Now, I think that we had something to do with it. Well, you know, we scientists do experiments by taking observation, working in a lab, doing modeling. How do historians do it? They just ask the people that made decisions. Trump was president of the United States, and he said a great many reputable scientists, he called us reputable, are telling us that such a war could end up in no victory for wipe out the earth as we know it. Think back to natural calamities back in the last century, the 1800s, volcanoes. Weather so changed. There was snow in July in many temperate countries. They call it the year in which there was no summer. Now, if one volcano can do it, talk about with the whole nuclear exchange, nuclear winter. And Gorbachev said, model by an American scientist, that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge of that was great stimulus. So that was 40 years ago. What do we want to, why am I here? I want to ask 2 questions. Although the Cold War and space race are over, could the remaining nuclear arsenals still produce nuclear winter? And there are now 9 countries, 2 other countries, much smaller arsenals had a nuclear war. What would happen? So the answer is yes, it would last a decade, kill most of humanity, as I'll show you, the US and Russia, and say a smaller war, say between India and Pakistan, nuclear winter, as temperature would get below freezing, but it would still, the direct effects would be horrific, as we all know, from blast, radioactivity, and fires, and still billions would starve. Now, nuclear weapons were invented by physicists, including some from here, and so I assume you all know what a nuclear weapon is like. But in case you forgot, I just want to show you. We used to test nuclear weapons outside in the atmosphere. This is the shot knothole test. You can see these dignitaries there with their fingers in their ears and sunglasses on. This is what the bomb looked like. It was like bringing a piece of the sun to the earth for a fraction of a second. And they built this house to see what happened. It's lit up. This was at night. It's lit up by the weapon. And as the fireball rises, the gets shorter and the building starts to burn. But then the blast wave hits like thunder following lightning and blowing it apart. You might say, well, that's going to actually blow the building, blow fire out. But actually, it would break gas mains, it would break electrical lines, and the fires would reignite. If you burn certain materials that are oil-based, you get this black sooty smoke. And it's this black sooty smoke that goes up into the atmosphere and causes most of the climate change. So let's go back to the first nuclear war. This is a map of the US Army of all the cities that they firefighted in Japan in 1945. This is a history we're not taught in our history classes. On March 10th, two airplanes went over Tokyo and made a flaming X out of napalm. And then about 300 more planes came with incendiary bombs. More burned to death in 24 hours after that than ever before or since in the history of the world. And then every 3 days or so, fleets of planes would go out and bomb all these cities. They drop bombs in the daytime because their bomb sites weren't good enough and they could be shot down. So they decided, well, you know, every house probably has a drill press out back, and so we're going to kill civilians. They killed 800,000 people. When it came to the last two, Hiroshima and Nagasaki, it was already a policy of burning cities. It was just Now, we can't burn cities, but occasionally it doesn't exist for us. There was a big forest fire in Western Canada in 2017, and we had a paper in Science about it, and we used the same model that we used to calculate climate response. Now we're using the what's called the WACCM model, whole atmospheric community climate model at NCAR. And we modeled it, and we saw with satellites that the smoke was heated and lofted. So here's one graph from the paper showing a rapid ascent of the aerosols by heating. This is the same process that we've modeled with much more smoke after a nuclear war, and the model did an excellent job of simulating it. Okay, but it's much worse than that. This is a Trident nuclear submarine, and the US has 14 of them, and the bombs on it are 100 or 500 kilotons, not 15 kilotons. So each Trident is as powerful as maybe 1,000 Hiroshimas. I just showed you 100 Hiroshimas. And we have 14 of them, and that's about half of our arsenal, 25,000 Hiroshimas. Russia's got the same thing, 50,000 Hiroshimas. That's what the arsenals are today. So when we did the experiments 40 years ago, there weren't general circulation models. So we used a one-dimensional model that modeled the whole world in one column. Or I used an energy model without any atmospheric dynamics. So we said, now we've got a GCM that can run very easily. We can have an ocean. We can run it for 10 years. And so we decided to go back and simulate what would happen for a full-scale nuclear war between the US and Russia. And we put in 50 or 150 million tons or teragrams of smoke. Now, this is the same scenario we used 40 years ago, but then we used a third of the arsenal, and it's the same. We can still do it today. Why? Because we use a third of the arsenal, but we put one bomb on every possible target in the US and Russia, and there's this huge pile of bombs still there. Okay, let's put two on in case the first doesn't. There were still 7 more. There were 9 times 9 bombs for every possible target, like rubble. So we can still do this today, and this is the smoke from the US-Russia war. It's much thicker, would last again for years. And this is the temperature change 1 year afterwards in June, July, and August. And this is the large temperatures would get below freezing. In fact, back then we said, let's take a place in where they grow crops in the Ukraine, just by chance. And let's look at that grid point. And the black is the normal minimum temperature from one of the tolerance. It gets warm in the summer, 20, 25 Celsius, 70, 80 degrees Fahrenheit, below freezing. And then smoke in on May 15th, temperature gets below freezing and stays below freezing for a couple of years. So clearly that would destroy agriculture. Now, we had trouble getting funding for this, but finally we got some funding from the Open Philanthropy Project, which is Facebook billionaires gave us money, Dustin Moskowitz and Carrie Tuna. And our paper, we said, well, you know, India and Pakistan are having a little mini nuclear arms race. And in a couple of years, they had 400 or 500 weapons, and a little bit bigger. And the target's a little bit bigger. So let's calculate how much smoke you would get from that. And it would be 12 up to 37 grams of smoke. So this is the global average temperature change scenario. Green is the US-Russia case, 10 degrees colder than normal. These are different India-Pakistan cases, and it would last for about 5 years. Now, during the last great ice age, when there were mile-thick ice sheets covering North America, the global temperature was about 5 degrees Celsius colder. These are ice age temperatures for several years. It wouldn't produce an ice age because once the smoke cleared, the sun would melt the snow that had accumulated. The orbits aren't in the right place. But if you plot this on the global warming graph, you've got to rescale it. This is 50 and 150 teragrams. And before thinking this, yes, so it's no problem. I did a calculation of that and published it on that academic journal, Huffington Post. And so I assumed that the smoke the emissions of CO2 up. So, but if you really want to put aerosols in the stratosphere to reduce global warming, you call that geoengineering or climate. And the idea is to emulate a volcano and put sulfur dioxide there. And so that would not kill people. So if you wanted to do it, that's a much better idea. I'm not sure that's a good idea either. If you wanted to know everything I think about it and my 28 reasons why that's not a good idea, I am giving a talk at 3:45 on Thursday at the EPS seminar. But what's the most important impact of climate change is food. So we wanted to calculate for every place on Earth for these different scenarios, how much you could grow. How would nuclear war affect food? It would make it darker, colder, it would make it drier. There's lots of other things there that it would do. We haven't had time to evaluate those. We looked at the main things: temperature, precipitation, and sunlight. I published a paper last year in Nature Food about what would happen. We took every country from Food and Agriculture Organization data, what crops do they grow, how much do they import and export, and calculate for each scenario how much you could grow. The world food storage is about 60 days worth. So we assumed that once all the food that's stored was used up, you would have to depend in the second year on food you could grow. And so we used part of the NCAR, National Center for Atmospheric Research, climate model, and we calculated the main grains: corn, rice, soybeans, and wheat, and grasses, which animals eat. And for cattle and sheep, about half are fed by pasture, half by crops. So what would happen if you had people eat the food that instead of vehicles? And we assumed that there would be trade would stop, so people would hoard their food like they did toilet paper a couple years ago. And we use this state-of-the-art model, Wacom, and and this is what we got. For India, Pakistan, for the different scenarios, depending on the number of weapons, the size of the weapons, you would get 5 to 47 teragrams or a million tons of smoke. For the US-Russia case, 150 teragrams of smoke. And the direct fatalities would be horrific. That's why we haven't had a nuclear war in 77 years. Remember what happened in Hiroshima and Nagasaki. I think we've been very lucky to have gone that far without another use of nuclear weapons. It would be horrific. But it turns out the indirect effects are even worse. So if we look at the temperature changes over croplands, before I showed you global averages, colder over croplands, because this would be in the middle of the continent, so it wouldn't have as much buffering from the ocean. And this is the change of the amount of calories. So there'd be 90% fewer calories available for several years for the US-Russia case, average over the world. For these cases, 30, 50% less fewer calories. What time do I have to stop, Chris? Oh, okay, great. So this is a little bit of detail what we did. I learned a lot about this. What's the average diet? So the average diet is about 3,000 calories, and the green is all the crops that we eat. The red is other agriculture. The blue is livestock, and the little sliver up here is fish. And where do the crops go? The bottom here, the thick one is what humans eat. This is what animals eat. So for corn, most corn is just for eating animals. For rice, most of the food goes to humans. Or wheat also, but for soybeans, a lot's used for feed. So we said, what would happen if we feed the animals, or if we take all their feed and feed humans? So we looked at several scenarios. A livestock case where we continue business as usual, feeding the animals and eating them. No livestock case where we let them die and we consume them in the first year. And we also included fish, but fish is a very small portion of the diet. And we did different fractions of keeping livestock alive. It doesn't make much difference. This graph right shows the number of people that would be alive or that would die in different scenarios, depending on what fraction we feed the livestock. It doesn't make much difference. So here's a map of the 37 teragram case. This is where 50% of the livestock feed went to human consumption, no trade. The brown is fewer than 5% people will be alive at the end of 2 years. The next color, this sort of orange, darker orange, fewer than 25% would be alive, 75% of people would be starving. And tropics, however, most people would survive because the climate wouldn't change as much and it wouldn't go down below freezing. But a US-Russia case, it would cause almost all the nuclear nations, everybody would die. Even if people would die in China than in US or Russia, even if no bombs are dropped there. So it would be horrific. Now, a couple cases, Argentina and Australia, most people would be alive. That's because the populations aren't very big. They're big exporters. And so if they distribute the food evenly, then they would survive. But if you think refugee problems are a problem today, think of these flotillas of hungry people headed for those places. So it's not really, I wouldn't move to Australia and forget about this problem. No way. And if you calculate the number of people that would starve to death, for India, Pakistan, 1 to 2 billion people would die, and for the US, more than a billion. And we did this with the latest data we had, which was from 2010, when the world population was 6.4 billion. "15 times more people would die by starving to death than would die from the horrific direct effects." Now, we still have more work to do. We didn't include violet radiation or surface ozone changes. Of course, there would be more complex economic responses. Maybe there would be some trade. Maybe the food wouldn't be distributed well within countries. Maybe farmers would try to adapt different crops, but it's really hard to scale up new crops if you don't know what you're doing and don't have the seeds. And how do we test this with analogs? So there's a seasonal cycle. Of course, it gets colder in the winter. It doesn't that much here in Berkeley, but most of farther inland it does. It gets dark, cold at night. And we have firestorms from cities I've showed you. And then what about the atmosphere? There have been dust on Mars, impact, called as dinosaur extinction, forest fires I showed you, volcanic eruptions. So, how do you feel? I took this at my 37th Bob Dylan concert before I took my camera away. So it's pretty depressing, isn't it? What do you do with this information? Well, as Mark Twain said to River in Egypt, it would feel better just after I said this, go home, hope somebody else solves the problem, hope Putin's threats about using nuclear weapons are just bluster and got nothing to worry about. People say, why do you even work on this? Isn't it really depressing? And I said, well, I'll prevent it. So I'm trying to do something. I want to prevent something like this from happening. Now, there are been treaties to deal with this. Some of them are about where there can be nuclear weapons. And some places say, we don't want any nuclear weapons. In Latin America, outer space, seabed, South Pacific. And this is a map showing nuclear weapons on Earth. Blue, there's no nuclear weapons. There's none in the Southern Hemisphere. None in places in Central Mongolia, Kazakhstan, Southeast Asia. The red countries are the ones that have nuclear weapons. There's one in the Western Hemisphere. United States, there's 2 in Europe, England and France, there's 6 in Asia. The yellow ones are ones that are in some treaties. Like the Canadians think that they're protected by NATO. The orange ones are countries that actually have nuclear weapons stored by the US, tactical weapons. Turkey, Germany, Italy, Belgium. Now, John Kennedy was president. He understood this problem 60 years ago. And he told the UN General Assembly, every man, woman, and child lives under a nuclear sword of Damocles, hanging by the slenderest thread, capable of being cut at any moment by accident or miscalculation or by madness. Weapons of war must be abolished before they abolish us. But as president, he didn't do that. Now, there were 3 conferences organized by the International Campaign to Abolish Nuclear Weapons around the world to inform them about the humanitarian impacts of nuclear war. They had Hibakusha there, people that had survived the Hiroshima and Nagasaki bombings. Setsuko Thurlow, who's still alive, lives in Canada, who told very moving stories. And they had our group talking about the climatic effects. And more than 100 nations sent ambassadors to these meetings. So I actually put a suit on to give up. This was a meeting in Mexico. And after 3 meetings, ICAN then went to the UN General Assembly and got a treaty, a ban treaty through the General Assembly. And they were very clever because they did not go through the Security Council, which has veto power. And the 5 permanent members, it's just by chance happens to be the first 5 countries with nuclear weapons, have veto power. So they could do nothing about it. And in the New York Times, there was not much about it. It was an article. A treaty has reached to ban nuclear weapons. That's the hard part. The hard part is getting it signed by the nuclear nations. The closest we come very close to having a nuclear war. This was in the Cuban Missile Crisis. I took this picture in Havana. There's a little museum there. This was given by, this exhibit is a replica during the early days of the revolution. There were 36 missiles there. Each one had a 1 megaton warhead. It says here 77 times more powerful than Hiroshima and threatening the United States. And John Kennedy called for a blockade of the Russian shipments to Cuba. And eventually they worked out a secret deal with Khrushchev to get rid of our missiles and they moved these, and it didn't, and we didn't have a nuclear war. Vasily Arkhipov was a Soviet submariner in a submarine off the coast of Florida that was being depth charged. And turns out they had a nuclear on there. And 2 of the commanders wanted to use it. Said, no, you can't do it. He got the first Future of Life award. And it turns out there were tactical nuclear weapons in Cuba that we didn't know about either. So I had a student, Juan Carlos Antuña, who worked with eruptions on using LIDAR and satellites to measure stratospheric aerosols. He had a LIDAR in Cuba and that the Russians gave him. And one day I got an email from him. After he got his PhD, he went back to his research. I got an email from him. The Cubans want you to come here to talk about climate change. I said, what? And I got invited down to Cuba and I gave this talk, and Fidel Castro came out, sat in the front row for an hour listening into my talk. And it turns out, you remember he fell down once and hurt his shoulder and his leg, and he also had, we think, probably intestinal cancer. He gave up control of government to his brother Raul, but then he got better and he had nothing to do. So somehow he discovered my work. And Juan Carlos showed me a website where he was talking to the head of the Cuban Weather Service. So he came and listened, and he signed this, and then he gave me his autobiography so I could practice my Spanish. And then today, this arrived at my hotel from Commander-in-Chief Fidel Castro, and there's a picture, and he got dressed up for the occasion. The next week, he blogged. He said, yes, we have to get nuclear weapons. And front page, he said, can we videotape, can we record your talk? It was shown in nationwide television the next day. The 4 pages in the Cuban newspaper, Granma had an article about it. And he said, the only way to prevent global climate catastrophe is by eliminating nuclear weapons. And so I was given this prior of Havana, and I was around, and I said, I'm supposed to be on TV. Let's go and sit to this hotel. There was a TV there, and there was a Julia Roberts movie on. It's a bootleg DVD. I said, can you change the channel? And sure enough, there I was giving a lecture. What that taught me is that a professor giving a lecture isn't going to solve this problem. You need to reach people's emotions, not their intellect. So imagine a movie where this beautiful scientist in St. Petersburg who meets this handsome scientist at a conference on the Kashmiri border. There's a skirmish going on, and you can, write your own script. In fact, if you can, please give it to me, because I know people like to produce a movie, but they need a good script and a little sex, and they save the world from nuclear war. So that's the way to do it. You don't have to be theaters. It could be on Netflix. But I'm still trying to get that done. Brian Toon from the University of Colorado and I are leading this effort. And we had an op-ed in the New York Times a couple years ago. So the conclusions are the current arsenal can produce nuclear winter. Nuclear winter could kill most of human. In a US-Russia nuclear war, more people could die in India or China than any in the US or Russia, even if no bombs are dropped there. There's a couple other things I didn't have time to talk about. Nuclear weapons can be used if they exist. A nuclear war could start tomorrow by accident, hackers, computer failure, bad sensors, or unstable leaders. Nuclear arsenals do not deter attacks from non-nuclear states or from terrorists or pandemics. You can think of a number of wars which nuclear states were attacked. Israel invaded 6 Days War. The Falkland Islands were invaded by Argentina. Their nuclear arsenal didn't do anything to help them. Who won the war in Vietnam? Who won the Soviet war in Afghanistan? The US war in Afghanistan. So they don't really help. Oh, but they're to deter attacks from other nuclear nations. Well, it's true. One nuclear nation can attack another nation. But why? Why is the world more peaceful? It's not necessarily because of that. In fact, if you say, I'm going to attack you with my nuclear arsenal if you attack me. If the US attacked Russia with our nuclear arsenal, let's say somebody told the president, bombs coming and you've got to launch your missiles, land-based missiles, in 10 minutes or you'll lose them. And they get launched and it turns out it was a mistake. We would launch our nuclear arsenal. We would all die from starvation. So the threat of using nuclear weapons as a deterrence, meaning like a suicide bomber. For it to work, they have to believe that you're crazy. It doesn't make any sense at all, yet it continues. The only way to prevent a global catastrophe is to get rid of nuclear weapons. And President Eisenhower, who warned us about the military-industrial complex when he was leaving office, understood this. He said, every gun that is made, every warship launched, every rocket fired signifies in the final sense a theft from those who hunger and are not fed, those who are cold and are not clothed. The world in arms is not spending money alone. It is spending the sweat of its laborers, the genius of its scientists, the hopes of its children. Yeah, go Ike. So the treaty to ban nuclear weapons came into force. 50 countries had signed and ratified it. And this happened years ago. In January 2021, there were 91 countries that signed it, and 68 ratified it, and the others are working to get it ratified. There have been Nobel Peace Prizes given for people that have worked to get rid of nuclear weapons. So Linus Pauling, for example, the International Physicians for Prevention of Nuclear War, Joseph Rotblat, the International Atomic Energy Agency, but in 2017, ICAN, the International Campaign to Abolish Nuclear Weapons, and Chris read what it was for. I love their symbol. They draw a blue and yellow cartoon for every Nobel Prize winner. Beatrice was the director of ICAN, and she accepted the Nobel Prize 5 years ago. And in her speech, she said, if only a small fraction of today's nuclear weapons were used, smoke from the firestorms would loft high in the atmosphere, cooling, darkening, and drying the Earth's surface for more than a decade. It would obliterate food crops, putting billions at risk of starvation. Yet we continue to live in denial of this existential threat. The story of nuclear weapons will have an ending, and it's up to us what that ending will be. Be the end of nuclear weapons, or will it be the end of us? One of these things will happen. The only rational course of action is to cease living under the conditions where our mutual destroying one impulsive tantrum away. And she said this, remember 5 years ago, Kim and Trump were arguing about whose button was bigger. So what can you do? Well, this Coalition for Nuclear Threat Reduction was started a little more than 2 years ago at Princeton, and it was funded by the American Physical Society for 3 years and the Carnegie Corporation, and now it's being funded by, it's hosted by the Arms Control Association. And there are team members who go around and give talks at different physics departments around the world, asking people if they want, telling people about their expertise. And you'll see Raymond John Loves from Berkeley is one of the people on the team. And so I've been doing it. And what is it? So we're asking you to join. And what does it mean? Well, if you join it, there are every month, every couple of months, you might get an email saying get a tutorial about nuclear weapons if you want to learn about it from the experts, or we'd like you to write to a member of Congress to ask them, or the president, to ask them to change policy. And we advocated for signing the New START treaty, which was about to expire, but just before Trump never signed it. It was renewed for 5 years as soon as Biden signed it, and so here's an example of a sample letter that will be sent around in a week or two. My name is, I'm a constituent and a physicist concerned about the dangers of nuclear weapons. I'm writing to ask you to support nuclear risk reduction and diplomacy with Russia. Even as the world rallies against Russia's aggression in Ukraine, now is the moment to renew disarmament diplomacy. And so I urge you to publicly express your support for the president's effort to press Russia to allow the resumption of inspections and negotiate a new treaty. So these are the kinds of things that the Physicist Coalition does. So I'll end just by quoting Carl Sagan, who was one of the first American paper on nuclear winter. People said to him, Carl, don't you want to keep our weapons as a deterrent? He said, for myself, he was a great communicator. If you haven't ever met him or seen him, go to look some of his old talks. He said, for myself, I would far rather have a world in which the climatic catastrophe did not happen, independent of the vicissitudes of leaders, institutions, and machines. It seems to me elementary planetary hygiene as well as elementary patriotism. So I agree, elementary planetary hygiene demands that we work on this to get rid of the weapons much faster than done. And I learned from this to keep our planet looking like for a long time to come. And thanks. And if you want more information, here's my website, or if you can spell my name, type it into Google, you get to me. Because nobody else has anything like that. And it has all of our papers are there.
Questions?
Yeah. The question is, how do we calculate how much do we get from cities burning? That's the biggest unknown. We've done it so far from looking at fires that burn in other places, other examples, and looked at and surveys of people in cities. And we've Brian Dunas is an expert on this, and we do proportional to population. So we look at the area. There were 13 square kilometers. We look at the area for different size weapons, and we look at what's there to burn. What we'd really like to do is explicitly burn cities. So there's a high resolution model called WRF, Research and Forecasting, WRF, at NCAR, which is used by many bureaus around the world for weather forecasting. And there's a version of WRF called WRF Fire, which is used to calculate forest fires. And so we have teams working on it right now in cities, and we want them to see what happens in a city. Is there enough fuel? Does the fire propagate, or does it stay in one place? And how high does it get? And what are the constituents of the smoke? So far, we've used pure black soot, but actually it would be more complicated than that. There would be carbon that would be coated with organics. So we have people trying to do their job, but that's how we do it so far. And I just want to mention, there was one paper written by a group from Los Alamos claiming that for the 5 teragram case for India, Pakistan, there wouldn't be enough smoke and it wouldn't get to the stratosphere. But by the first author was Reisner. But they made several fundamental errors. they didn't allow any moisture in the atmosphere. So when convection happens, the energy is like the heat of condensation. And David Robs here did a calculation that showed that, and several other people have too, that if you ignore heat, you get it wrong. They also wouldn't tell us what they burned, but we found out they burned a place in suburban Atlanta, Georgia, which included a golf course and a country club and a school and widely spaced homes. So there was very little fuel there, not like a lot of fuel in the middle of the city. Now, people say, well, you know, cities nowadays aren't made like Hiroshima, they're made of stone and steel, but it's really not the frame of the building that burns, it's the concept that gets crushed, and the fire takes several hours to burn. The people at Los Alamos only ran their model for 40 minutes, and they had very strong winds, so they wouldn't allow the chimney to grow. So I don't know why they made all these assumptions that would limit the amount of smoke. I can just speculate about why they did it that way. But several people have repeated it, including a group at Lawrence Livermore Lab, and have gotten the smoke up into the stratosphere. So the question is, where does the smoke go after it comes out of the stratosphere? It gradually settles due to gravity, and most of it comes out in the. We can look at ice today to look at where the sulfur goes from big volcanic eruptions, and you can take an ice core and measure these layers of sulfuric acid and quantify it. And for Mount Pinatubo, which is the last big eruption in 1991, we have a lot of data on what actually went into the atmosphere. And it turns out that less than the global average of material ends up on the ice. So if you take the amount per square kilometer, you got to multiply by more than the area of Earth to get the total amount. Because it's not, but the great thing is it stores it there. A lot of it comes out during in the mid latitudes along jet streams. There are these folds in the tropopause where you get mixing between the stratosphere and the troposphere, and rain washes it out and it goes away. But aerosols that get stratosphere out of Antarctica and Greenland, and we have measurement of those. And we actually can see in Greenland that the amount of tropospheric pollution from soot is decreasing the last several decades. You can measure that in Greenland ice. Suppose what?
Suppose that the world acts sanely. I know it's
the world acts sanely. Yes.
And we sign the treaties and we meet it, and we start to eliminate the bombs. And 5 years from now, I'm going to one of the pictures, there are no more bombs. But suppose there's 1 or 2 bombs in there, and there's keep 1 or 2 bombs. I mean, out of the thousands of bombs we have, that nobody's going to shoot, and how many bombs can we tolerate?
Okay, so the question is, what would happen if we actually started to reduce our nuclear arsenal? If somebody cheated and kept a few bombs around there? So when the arms race ended, the Nunn-Lugard, it was passed in the U.S. Senate by a Democratic and Republican senator, gave money to Russian engineers and scientists to dismantle their nuclear weapons and send the uranium plutonium back to the United States so it could be used as fuel for nuclear reactors. So nobody would steal it, so that people would still have a job, so terrorists wouldn't get a hold of it. It worked very well. So we know how to take them apart. We know how to dilute the material, and you could, under inspection, have them all dismantled and diluted right away, rather than somebody. And right now, exactly where the U.S. and Russian bombs are, with the New START treaty, each country can have 1,550 strategic weapons, but each airplane counts as one, so it's maybe 2,000. But until the pandemic, there were intrusive inspections. American inspectors went into Russia, Russian inspectors went into the US, they opened up the cells, they counted them. So we knew what each country had, and both countries followed the rules.
Suppose there's a sneaky guy that just
Well, so any use of a nuclear weapon, it was dropped on people. But if one or two bombs were used, it would not cause global climate change because there wouldn't be enough smoke.
Yes.
I can't hear.
Technologies being developed, like if there were so much smoke in the air.
Okay, so is there a way to take the smoke out of the atmosphere? Not that I don't know. But there are people that have an idea to plan for nuclear winter or a volcano eruption or asteroid impact. And that is manufacture short-lived greenhouse gases that decay over a couple of years and have huge tanks of them stationed around the world. It doesn't have to be around anywhere. And if you get this rapid cooling, you could release gas would trap energy for a couple of years and extract it. In fact, I'm reviewing a paper, a revised paper about that right now. There's a few things wrong with that. It would cost trillions of dollars. You would have to save these tanks for maybe decades. Somebody have to be in charge. You have to make sure they don't leak. So there are people thinking about that, but I don't know of any way to actually clean out the stratosphere, even from a volcanic eruption or from the smoke.
I guess you talk a lot about right? You mentioned the talk about feeling more than reason discussing this, and I guess people go on and I think we talk about that. I guess from the policy side, I think has gone on for a while. But you kind of explain away the whole fact there hasn't been a major nuclear war between nuclear power in the last 70 years. 50 years. And they say, oh, we're not fighting the war because we're fighting nuclear war. I was really confused.
So your question is, why has there been a nuclear war? Another nuclear war?
Also, I don't think that nuclear weapons.
So you're asking me why weapons don't play a key role in preventing conventional conflict, and why there's been a nuclear war. Well, of course, this is not my area of expertise, so but I will speculate. If you look at it, we've been very close to having a nuclear war several times. Stanislav Petrov got the second Future of Life Award. He was a Russian air defense commander. And one day it looked like there were 5 weapons coming toward Russia. And he looked at that and he said, you know, that doesn't look like the way they attack us with just 5. My orders are to go pick up the president and start a nuclear war, but I'm not going to do it. There was something wrong with the equipment. They were actually seeing reflections off of clock. Another day, there was a sounding rocket that was launched, and they told everybody they were going to do it, but the message didn't get Russians. And if you look toward the way behind it, it was coming from the United States. They almost woke up the president to start a nuclear war then. At the time, a training tape was put into the air defense of the United States. And the U.S. Defense Secretary was woken up in the middle of the night. We're being attacked, wake up the president. And it turned out it was a training tape, not the actual thing. So there are many times when we came close. Planes have dropped bombs, lost bombs. And so I think we've been really lucky that we haven't had a nuclear war. Now, no person would use nuclear weapons, but how can we be sure that sane people are the only ones of nuclear weapons? Putin has threatened to use them. He's not really threatened, but he did. But the Russians didn't actually take any action to activate their nuclear forces or take them out of storage. And some people think he was just bluffing, but that didn't win a war against Ukraine. So that wasn't very useful to threaten to use them. a counterexample where Ukraine did not ever have nuclear weapons that were based in Ukraine were Russian nuclear weapons. And Belarus and Kazakhstan also had their weapons there. But as soon as the Soviet went away, they took their weapons back. So Ukraine never had control of the weapons. So it wasn't like they could have kept them and used them as to defend themselves.
US people are and pressuring various different administrations towards forgot to use smaller weapons. This is a response to these studies that we would somehow have like a sane pivot, like to avoid this large global disaster, but we still have, slightly less devastating weapons. And so like what is our response?
So the question is that they're talking about using yield nuclear weapons in this arsenal, and is that a response to our work? Not that I know of. And I've talked to some commanders. I said, so I've got a dial on this. I can dial it down or up. Which way am I going to dial it out to a war? Why would I ever dial it down? And once nuclear weapons are used, how can you guarantee that the war won't escalate? How can you guarantee that under the fog of war, people get scared, communications break down, their data is false, they don't just fire them. Should read Dan Ellsberg lives a couple of miles from here up in Kensington, and should read about how close we came during the when he was working in Washington, where some weapons were just. He said it's not true that only the president nuclear weapons. The people on the ground can do it, and they're planning. You lose communicate what you should do. So I think we've been pretty lucky they haven't been used. But I think that another thing, we're telling Iran we don't want you to have nuclear weapons. It's like you're sitting in a bar telling people not to drink. Do as I say, not as I do. Why should they even listen to us? Why do these 5 permanent members of the Security Council think that they are special? They should have, everybody shouldn't. If we think we should have nuclear weapons, doesn't that imply every country should have them? Why are we different? So and when the New START treaty was signed between Obama and Medvedev, the New START Strategic Arms Reduction Treaty, he had to get it passed through the U.S. Senate to be ratified, and he needed a 2/3 vote. He made it with the Republicans that, okay, if you, which they did, modernize our and now it's more than $1 trillion that's being spent to build new missiles. The missiles they have now are perfectly good to build new submarines, new bombers, to build new missiles that will get put in the ground and buried there and never used. So it's part of it is motivated by money, by making money on it. So that's also a big problem. Imagine, what if you're one of the people that's sitting in a bunker in Montana underground, and there's 2 of you there that have to turn the key to launch a weapon, and you get a command to launch your missiles. Would you do it? What does that even mean? Does that mean that the U.S. is starting a nuclear war? Does it mean that deterrence didn't? So we're just going to kill millions of people? You've got to really brainwash people to do that job, to sit there and be and do it if you're told to do it. So it's and now I just read that a lot of people that have been those fellows are against her because they're creativity in their work in the past, and that takes a while. So this whole thing, and if we got rid of our nuclear weapons, the world would be much safer. If you think that using violence is the way to solve them, we've got very precise cruise missiles and other weapons that we could blow up anything we want. Why do we need these weapons that will kill so many people at the same time and not be peacekeepers?
I was talk about the relationship of nuclear winter and the burning of the Kuwaiti oil fields?
Yeah, so when during the Gulf War, the Kuwaiti oil wells burned, I showed a picture of that. Carl Sagan came out and said, oh, that's gonna cause nuclear winter, but it turns out he's not a meteorologist. He was wrong about that. There was a high pressure system over the Middle East with a strong inversion, and there wasn't enough smoke, and it was trapped by the inversion and didn't have enough energy. It looks horrible, all that smoke, but it's coming from oil well. It's not coming from gas fire many square kilometers across with much more energy. And so people have done calculations since then and shown that what happened agrees with the current models. There was some smoke found in the Himalayas. Some smoke got transported around, but although it looks horrific, it wasn't enough smoke to cause climate change. In fact, I wrote a paper, people say, well, Hiroshima and Nagasaki, there was a nuclear war. Why didn't that cause nuclear? I went and looked at those 69 cities and calculated how much you would get from them over that summer of 1945 and how much climate change it would cause. I published that in the Journal of Geophysical Research. And I looked at data. So the data, ships wasn't very good. So I used land-based surface temperature data. And there were two stations measured sunlight, one here in California, one in Chile. I looked at their data, but they had to be sure there weren't cirrus clouds. So it looked like a little bit of a dip. And I calculated that the global temperature change would be about 1 or 2 tenths of a degree Celsius for a couple of years. Now, how do you detect that? So we looked at climate models, some model simulations that have done simulations of climate for that period. And the climate system is chaotic, it's noisy. And so it goes up and down, and the temperature can go up and down by that much every year. And if there was a signal, you could detect it in the observation. Well, you already asked the question. Do you want to? So the question is about radioactivity. So that's what people are scared of activity. They see the damage it did in Hiroshima and Nagasaki. Radioactivity indeed is not good, but it's local pollution. So it depends on the wind that day, and it will downwind. It also depends where the bomb is dropped. If it's a land, but if it's dropped on the ground, like to blow up, a lot of dust will come up. Radioactive, but it will fall out pretty quickly because these are large particles. If it's which is what we model to cause large destruction, it wouldn't produce a lot of a particle. It would just smoke. There would be that. So we're calculating that now. We're doing a calculation down in a plume. Locally, there would be radioactivity, but it wouldn't be global, and far away from there, it wouldn't be a problem. Thanks.